All right, everybody, this is your instruction for the FID that you have on January 19th, Friday, January 19th. So the first thing to start with is, if you haven't already done this, to check the homework that was posted on Google Classroom, pages 34 and 37. Open up that answer key and make sure that your graphs are all good and your inequality solving. If anything is not correct, make a note of it. And if you're not sure why it's incorrect, make a point to ask me about it before you do your unit test at the end of next week. All right, so for today's instruction, we're going to be looking at the following three pages, 38, 40, and 42. So the expectation is that you have notes fully copied down and ready to discuss if necessary in class on Wednesday. And the homework assignment is page 39. So that'll be individual work for you to do once this instruction is done. And I say Wednesday because, again, I'm going to be out on Monday and Tuesday. So on Monday, you'll be completing page 43, working on the Unit 5 study guide, the first part. Tuesday, you'll be completing the study guide at the end of your packet and working on Delta Math. All right, so for today's notes, let's go to page 38. So if we are doing absolute value inequalities with one variable, it's going to work differently than what we did in class earlier, where we had two variables graphing it on a grid. So the first thing you want to do to solve an inequality that has absolute value in it is isolate the absolute value bars. Then you're going to make two separate inequalities. The first one comes from just dropping the absolute value symbol off and keeping everything the same. The second one, you're going to drop the absolute value symbol again, but you're going to change the direction of the inequality and make the non-variable side negative. So we'll have to switch a couple of things when we solve it the second time. You're going to solve for x, you're going to write your answers to inequalities and put them on a number line. If the shading is in the middle, you're going to put the word and in between your answers, or you can write it as a compound inequality, as you see here. If the shading is on the outsides, then it's going to be an or situation, and you'll just write the word or in between your answers. All right, so let's look at a couple examples of this. All right, so for the first one, we have our absolute value bars already isolated. So there's not a whole lot of work to do on this one. What this means, just so everybody understands the concept, is that the quantity inside these bars is less than 2 units from 0, because absolute value is defined as units from 0. So we're saying that this distance from 0 is less than 2, which means it could be less than 2, or it could be greater than negative 2, because greater than negative 2 would also be less than 2 units from 0, if you can picture where that is on a number line. So the first time I solve it, I go less than 2. The second time I solve it, I go greater than negative 2. So in practicality, the x plus 2 stayed the same, but the first time I solved it, everything stayed intact. Second time I solved it, the less than symbol turned to greater, and the 2 became negative. So we have to solve it two ways and get two answers. First answer comes out to less than 0. Second answer comes out to greater than negative 4. Now, whichever one of those two answers is lower, you need to put that on your number line first. We don't want backwards number lines. It's going to mess up everything. So negative 4 is lower than 0, therefore it comes first. 0 comes second. These are inequalities without equal signs, and so they're open circles. And if I go lower than 0 and greater than negative 4, then I have a section in between that gets shaded. All right, so the directionality tells you which way to shade it. And because there are numbers that exist between negative 4 and 0, I put an and in between my answers, or I write it as a compound inequality, where x goes between the two boundaries. Always point your symbols left. So if you're writing an inequality from an and answer, point your symbols left, put x in the middle. All right, example 2. So in example 2, I have some isolating to do. So I need to add 2 first, then I need to divide 8. Once I divide 8, I get 4, and I set up my two inequalities because now the bars are isolated. So negative 2x is the inside part. It does not change to positive 2x. You just leave it exactly as it is. Greater than 4 because that's how it started. Then less than negative 4 because I need to switch everything. When I divide by a negative, the sign flips over, so I get less than negative 2. This sign will also flip over, so I get greater than positive 2. It's impossible for a number to be both less than negative 2 and greater than positive 2. So you put or in the middle instead. Part of the graph is pointing left, part of the graph is pointing right, open circles because of the inequality type. All right, so this is a divergent graph because it's impossible for anything to be true in between. All right, finally in this section, I have to add 4, and I get a quantity that is greater than 9. The absolute value is greater than 9. So again, what that means is more than 9 units away from 0. That could be greater than 9, or it could be less than negative 9. So if I solve it greater than 9, I get 13. If I solve it less than negative 9, I get 4. So if I go 4 first, because that's my lower boundary, 13 next, and I want to go less than 4, so that's to the left, go greater than 13, that's to the right. Again, open circles because there was no equal sign in the inequality. Generally speaking, if you have a greater than symbol on these, it's going to be or. And if you have a less than symbol, it's going to be and. Because less than means between two values, and greater than means beyond two values. All right, moving on down, graphing quadratic inequalities is different. So to graph these, you have to find the solutions to the quadratic as if it was an equation. Usually you can do that by factoring. You're going to get 2 answers, and those will be your boundaries. Your answers will either fall between your boundaries or beyond your boundaries. More on that in a second. So you plot the boundary points on the number line. You're going to test the value. You're going to shade the correct part of the number line. Then you're going to write your algebraic solution using inequality format. Now I've got a note here next to number 2. You should always be testing 0 if you can. That's the easiest number to test. The only time you wouldn't be allowed to test 0 is if 0 is one of your boundaries. Then you have to use something else. All right, let's look at an example. I do want to go in these one at a time again. And I want you to take your time with this. So if you don't catch on right away, I do want you to pause and go back and listen again. So anytime I go to solve a quadratic equation, I have to get a 0 first. So 12 was subtracted to the left. And then I tried to factor it, and it did factor. This is a good time to pause. Don't just write these down. Try to factor it yourself and see that it does, in fact, come out to these 2 factors. Solving it means set each one equal to 0, so I get negative 3/2 and positive 4. Those are not the answers to the problem. Those are just the boundaries to the inequality. So negative 3/2, positive 4 are my lower and upper boundaries. Always put the lower number first, like I mentioned before. So now I want to test 0. Where does 0 fall? 0 is in between these numbers. So by testing 0, what I'm doing is testing all the numbers that are in between these 2 values. If 0 works, so will all the others. If 0 doesn't work, then neither will any of the others. So go ahead and plug 0 in for x. You're going to get 0 minus 0 on the left side of the original problem. Is 0 less than 12? Yes. So 0 is true, which means everything else in that same region where 0 is will be true. And I just shade it all in. If 0 was false, I would leave it blank, and I would shade the outside sections. You don't need to go and test the outside sections because either the inside's going to work or the outsides are going to work. So if you get a false, you can be sure that the outsides are true. Okay, so next problem. Take this shading off now. Again, I need to have 0. This time I was already given 0, so I'm good to factor x minus 5x plus 1. So x would equal positive 5 or negative 1. Negative 1 is lower, so that goes on my number line first, then positive 5. And I test 0. 0 is between again. 0 is not always between, by the way. So you could have answers that are positive 1 and positive 5. And then when you test 0, you'd be testing the outsides. But 0 falls in between again here. And when I plug it in, I get a false statement this time. Because 0 minus 5 is not greater than 0. So because it's false, I leave these blank. And then I would shade the outside parts. When I'm shading the outside parts, it's impossible for both sections to be true, so I need to write or to show that I'm either this or this. And so I have a compound inequality with or in between. With the example, I just mentioned a second ago that 0 doesn't always fall between the numbers. So like I said, if you get positive 1 and positive 5, and you go to test 0, what you're really testing is this left section and also the right section because the outsides go together. So just know that you're not always testing the middle. When I did get an answer between, I have to put x between, and I always point my inequality symbols left. But when it was on the outsides, I put an or, and I list them twice. All right, if there was anything confusing on that, please make sure you make a note of it and be sure to ask about it so that we can get that cleared up. All right, page 39 has your practice problems for absolute value and for quadratics. There are 2 changes to make. Number 6 ended up being a repeat of one of the example problems. So I just want you to switch that. You can pause here and write that down. And number 12 also needed to be fixed because number 12 was also one of the example problems. So switch that one as well. And this is where you'll be doing your practice. So what I'm expecting is you will factor all of these after you have a 0 and solve them, put the boundaries on, test the section. With absolute value, I'm expecting you'll isolate the bars. You'll solve it once positive, once negative, flipping the inequality symbol. All right, so you'll do that on your own. If you go over to page 40, so these problems are about optimization, which is to make something the best it can be. It's either going to maximize if we're talking about profits, or it's going to minimize if we're talking about cost. Every one of these problems is going to have a set of constraints that require an inequality to show what that constraint is. So that could be keeping a quantity below the amount of resources you have, or it could be something about the hours that are available for people to work on these things. Whatever it may be, there will be constraints on the problems. These are all real life situations, so we'll be using quadrant 1 only. So there will be no negatives. Therefore, the constraints will also contain x greater than 0 and y greater than 0. The optimal value is going to be the section of the graph that is on the vertices of the feasible region. So what I mean by that is after you do all your inequalities on the same grid, you're going to get one section that is overlapping, that's going to show the overlapping shaded regions. There will be vertices around that section. One of those vertices is going to be the best choice. It's going to be the optimal value. All right, to tell what the optimal value is, you're always going to need to write an objective function. And that is the function that is used to find the best value, the max or the min. Usually has to do with cost, or it could be about profits. Once you have the graph, you're going to look for the vertices, the intersection points, and you are going to test each one of those vertices in the objective function. All right, let's go over to page 42 and see one of these as an example. So you're stenciling wooden boxes to sell at a fair. And it takes you 2 hours to stencil a small box, 3 hours to stencil a large box. So we have that info right up front. We have a certain amount of profit we make off of each type of box. There's a certain number of hours that we would like to spend doing this project. And we want to sell at least 12 boxes so that we can actually make a profit off of these. So there's a lot going on here. Let's look at the end of the problem first so we can see how to set this up. Let's see if I can get some shading on here. Yep. Okay. So the last sentence says, how many of each size box should we stencil? So immediately that tells me I don't know how many small boxes to make and how many large boxes to make. So that should be my variables. X is small boxes, Y is large boxes. Also, I'm trying to maximize profit. So my objective function should be about profit. My objective here is to make as much money as possible. So the amount of money I make per small box is 10 bucks. The amount of money I make per large box is 20 bucks. Once I get the potential combinations of large and small, I can insert them here for X and Y, figure out what gives me the best profit. All right, I'm going to come back to this vertices section in a minute. Let's talk about the constraints. The constraints here are about the hours I have to make these boxes. It takes 2 hours to make a small box. It takes 3 hours to make a large box. When I combine all of those hours, I have to stay under or equal to 30. And that's because I don't have more than 30 hours available. So that's my first constraint. I'm going to graph that, I'm going to shade it, and that'll be part of the problem. Second part of the problem says I want at least 12 boxes to sell. So when I add the small boxes plus the large boxes, I need it to be bigger or equal to at least 12. So that's the second one. Notice I've done some intercepts here, and that's just so I can tell how to graph this the best way. I will have positive values as well. So the first one has an x-intercept at 15, if I divide 30 by 2, has a y-intercept of 10 if I divide 30 by 3. The x and y-intercepts of the second one are both going to be 12. So go in a graph. I know that I can go by ones because I'll be able to fit those intercepts on there. So first I labeled my large box axis and my small box axis. All right, I've got one line connecting y equals 10 to x equals 15. I have another line connecting x equals 12 to y equals 12. And it said that the 10 and 15 was a constraint that I had to be under. So I'm shading under that line. The 12 and the 12 was my boxes produced, which needed to be over. And so the section that qualifies for both is under the 10-15 line and over the 12-12 line. So that's what I'm shading in here. There are 3 vertices to this section. There's 15, 0, there's 12, 0, and there's this point at 6, 6. one of those 3 points will be the best profit. Now, if you think about this, it's impossible for 12.0 to be the best profit, because whatever that profit is, it's going to be higher over here at 15. So I don't have to test 12.0 because I know just moving horizontally that 15.0 is going to be better. Likewise, if I had this section shaded, I would never have to test the lower y-intercept. I could just test the higher one, right? But I do have to test 6.6 because that's a potential best profit. So I have two vertices to test. When I plug in 6 and 6, I get 60 plus 120, which is 180. When I plug in 15 and 0, I get 150 plus 0, which is 150. The best profit ended up being when I use 6 and 6. So the objective function is designed to meet my objective in the best possible way. And 6 and 6 turned out to be the best one. But you only ever have to test the vertices and only the ones that could work. All right, so that's page 42. So when you go to your classwork on Monday, you'll be doing page 43 the same way as page 42. You will be doing page 39 the same way as page 38. All of that needs to get done. Then you're going to go and work on the study guides. Your test will be Thursday and Friday next week. If you have any questions about anything that was covered here, shoot me an email and I will try to straighten it out. All right, good luck.